just share your slide?
Yeah.
Yeah.
Okay, let me start from the neural network thing, right? So I was talking about how this neural network came into the picture, and this Rumelhart-Hinton, they actually incorporated back propagation algorithm in the neural network structure, for which we have right now this sophisticated neural net. And then there came Vapnik-Cortez with the like latest invention in 1990s with support vector machine. It got really good feedback from 1990s to 2010. Even these days, people uses support vector machine to classify, to get nonlinear separability in the data set. So then finally, the deep neural network came into the picture with the hand of Hinton and Lacan, Yusuf Benjio, all these people came up with the algorithm. So what is the idea of this neural network? So the idea of neural network began as a model of how neurons in the brain functions. So there is a connectionism in our brain, and they are connected neurons. They are going to incorporate, or they are going to, there is an interplay between themselves to take any decisions. Like I am going to tell you all this, and you are going to remember a certain portion of this, and you are going to forget some of this. So that's what connectionism means. So okay, so in 1943, neuropsychologist Mascula and mathematician Pitts came up with the idea, and what they created an algorithm which will help to understand the brain of a fly. So they take some certain decision, the eye of a fly, which underlie and determine its free response. How this fly actually take all these decisions. They try to come up with a particular algorithm which is perceptron net, which actually help to understand their decision making process, because human decision making process is very difficult. You think about hundreds of thousands things at a single point of time. But understanding brain of fly or animals is really easier than those. Okay, so what they created one perceptron machine. How does it work? So these neurons take some input, they give some weights based on some selected criteria, they take a sum of inputs, cross product of weights, dot products of weights, and then they take a sum of that, and based on a particular threshold function, like if it is greater than half, we'll tell it is yes, or if it is less than half, we'll tell it no. So based on a threshold function, we are going to classify certain objects. So this has limitations, like it is based on some threshold activation function. You have incorporated yes no kind of activation function. If it is greater than something, we'll put yes or no. So it has a robustness problem. So what are the solution to that? The solution are feed-forward neural network, radial basis neural network, and Bayesian neural network. And in below, I have given the example of XOR problem. You cannot draw a single line to solve this problem. You need a hyperplane or some like set of like lines. So how this neural network really works? So like I'm telling you something, I'm giving you inputs. Your brain is this hidden layer where all these informations are going. They are playing within themselves. And finally, if I ask you a question, you are going to give some response. It can be right, it can be wrong, doesn't matter, but like there is a learning algorithm which is working in your head. So NN is composed of several perceptrons. Those are arranged in multiple layers. So first layer is input layer, second layer is hidden layer, third layer is output layer. Then these nodes are interconnected with the input layers and the output layers. So for feed-forward neural network, we assume the weights are going to in the direction of forward, not backward. That's why we call it as feed-forward neural net. Like you see, the inputs are connected with the hidden neurons in the forward direction. So all these nodes in this particular feed-forward setting are assumed to be connected with each other. So right now, let me just get into deeper how this really works. So we have a feed-forward neural network with input layer x1, x2, x3, x4. we are going to give some weights and connect this with the hidden neurons. We have total 3 hidden nodes, and we have a finally output nodes with which the hidden neurons are connected. So by this integration sign, I mean nonlinear activation function. By this summation sign, I mean weighted sum. And by this V and W, I mean weights, connectivity, connecting weights. So what we have, we take a sum of WI1 with HI and create one particular hidden layer. And in between, we incorporate one particular activation function. Let me just do it in a very sophisticated manner. So what we have a xcul vector of x1, x2, xd set of features, d-dimensional feature we have then h1, h2, hk is the vector which incorporates the hidden neurons. That's the hidden layer. And what we are going to do, we are going to create a hidden neuron hk, which is a function of wk transpose x. So I am going to take some weighted sum. So f of some weighted sum of wdk into xd. So what we are going to have in first hidden layer, it is nothing but these red connections, red lines along with those xi's. Okay. So we are multiplying x1 with w11, x2 with w21, xd with wd1, and taking a summation of that and taking a function of that. Means we are going to have some hyperplanes, and along with that the hyperplane can be non-linear, like logistic regression function. You try to think of logistic activation function. Then what we are going to finally get as output, we are going to finally get as output those v1, v2, vk, the particular weights given between hidden layer along with the output layer, and multiply them with the hidden layer. So we are going to carry out the calculation of hidden layer based on a functional form of weighted sum of weights as well as the inputs, and finally going to get the product of second this like particular hidden layer to output layer, all those particular weights as well as the hidden layer to determine my output layer. And if it is a classification problem, we will use a particular threshold function while taking the decision. So that's how really a neural network works. And to choose this particular f, there are a lot of such suggestions are there. So we can choose a fx to be sigmoidal function which lies between 0 to 1, and it has some really good properties which makes it suitable for FFNN model. Then we have tan h function, which is nothing but lying between -1 to 1, and then we have the current state of the art, which is called rectified linear unit, ReLU function. It's a maximum of 0 to x, and it's currently very cheap to compute and very useful in the neural network framework. So we learn parameters, all these wi's and vi's. The computation is really difficult, really challenging as well. So how do we really going to get those wi's and vi's? So finally finding f depending on the data as well as your selection. You can take any f, sigmoidal, tan h, ReLU based on your data set, or maybe based on your expertise. Then finally you are going to find out these wi's or vi's. So if you are really accustomed with operation research, you might have heard of gradient descent algorithm. If you have not heard of, it's an optimization algorithm which uses the data and try to optimize the particular weights based on certain criteria. So what we are going to really minimize, we are going to minimize loss function. So loss function is something like L1 loss, L2 loss which have been described in the previous section. Maybe mean square error is an L2 loss. We are going to minimize that, and based on that we are going to find out W1, W2, WK, V1, V2, VK. Like what we have done in linear regression, we are going to minimize the mean square error and finally find out the parameters of linear regression model. Similarly, the same thing we are really interested to do it here, but here we have a large set of weights and we cannot solve that particular differential equation. Like the particular derivative forms, we cannot really solve it by using basic mathematics here. That's why we have incorporated gradient descent technique and chain rule, and combining them, people created backpropagation, which is incorporated by Rumelhat and Hinton in the neural network architecture. And that backpropagation is going to help you to optimize those weights. So in neural network, what we have given set of inputs, we have connected it with a hidden layer with some sort of weights or connectivity, and those weights are going to be calculated by backpropagation algorithm, which nowadays machine does it for you. And finally, we are going to find out one map from hidden layer to output layer to finally get my required output. So one hidden layer neural network is mathematically very understandable. Not really, it's an like black box type model. So that's why statisticians really loved feed-forward neural network. And statisticians like Lugosi, Gabor, they came up with the asymptotic property of neural network, statistical properties, its consistency properties, all these have been derived by statisticians. So we are finally talk about how this backpropagation works. So I'm going to be little non-technical because the set of bright minds who are going to attend these workshops are really versatile in nature, like their backgrounds are really very versatile. So I am going to stick to non-technical questions. So we have some set of forward pass and set of backward pass. What forward pass do? It computes the errors. So we have that mean square error. We compute that error using the current parameter. So we put some current parameter, initial parameter as values 1, 0, 0 or 0, 0, 0, 1, 1, 1, something like that. Then backward pass compute the gradients. So you have heard of gradients, how it is used in finding local maxima, local minima in your calculus classes, and update this parameter starting from the parameter at the top layer and then moving to the backward layer. So that's why I have given the pinkish direction for the backward pass and the bluish direction for the forward pass. Any good, I mean, it's also good for reducing various computation. So you really can really recompute these parameters again and again so that we can get minimized error. So that's how really a particular neural net works, a particular feed-forward neural net works. So we can introduce some more layers and call them hidden layer 2, hidden layer 3 like that, and we can get some complex neural network. But the more complex you will go, you will be losing your interpretability. So there is a famous theorem by Hornig that's called universal approximation theorem. What does it say? Any particular one hidden layer neural network with sufficiently, please emphasis on the particular word, sufficiently large number of hidden nodes can approximate any function. So how many hidden nodes you are required in this particular hidden layer to really going to find out, to really going to approximate any type of classification problem, any particular function? That's really an unknown and unsolved problem. If you're really going to solve that, people will be like praising you a lot, because that's a really unsolved problem since last 40 years. And what is the question? So the results of this universal approximation theorem is true. It's theoretically feasible, but in practice, we really need to go for more hidden layers to really understand few problems, like the image data problem. We have 1 crore of image, we have 10,000 features. We cannot really work with one hidden layer neural network. And stochastic gradient descent, this backpropagation algorithm, is even these days most useful method for weight optimization. The neural network weights or connecting weights between hidden layer with the input layer and output layers are going to be calculated based on stochastic gradient descent. So now people will ask me this question, how do you really differentiate between this fat, small or short height neural net, which is called deep neural network, along with the tall and slim neural network, which is shallow neural network, which I introduced right now. In general or in particular in lives, we will be usually preferring a guy with height to be larger, I mean taller, and he should be healthy. Healthy means these days being being healthy means you are very zero figure type of thing. But like in neural network scenario, what we are going to prefer? We are going to prefer the fat and small sized neural net. Small in the set in the sense of like deep neural net. So an informal justification is deep models can really reuse computational subroutines and more compact in nature. That's why we really prefer a huge number of hidden layers rather than putting all the hidden neurons in one hidden layer and creating a feed-forward neural network. But that's true only for large sample problems or high dimensional large scale problems. For small and medium sample size, what do you mean by small and medium sample size? Sample size of 100 to 10,000 or 1 lakh is meant as a small and medium sample size. So beyond that, we can really work for deep neural net architecture rather than this shallow network. So as we say, we have some positivities and negativities based on this neural net. So it enables to understand nonlinear mapping. It enables to understand the data without making any pre-assumption about the data, which really is done by linear regression, other regression techniques like LDA, logistic regression. All these understands the data, but understands the data from its previous nature, like assumption, normality assumptions, homoscedasticity, and all this. So neural network is not going to take any such assumption and work on distribution free nature. And neural networks are very flexible for understanding missing data and data, but it has some problems. It cannot deal with, ANN cannot deal with particularly with temporal data. What is the solution? You have recurrent neural network for them. Neural network when applied to limited data, suppose you have 100 or 200 data sets, like COVID data forecasting. I am reviewing a lot of paper on COVID. So I have written some paper on COVID. So based on that, I have got very much review informations. So I am reviewing some papers which have used LSTM. That's a very deep neural network architecture for understanding time series datasets, forecasting time series dataset. So they have used 100 of samples of COVID and forecasted that based on LSTM. My question was like, are you crazy doing that? It will surely overfit. You have hundreds of parameters to optimize for 100 samples. Does it really worth? I think it doesn't makes any sense. So it will simply overfit. So if you have very small number of samples, do not go for neural network. Stick with classical approaches. And there is something called no free lunch theorem. Like in our workshop, you are not going to get any free lunch. Like if it used to be offline, we could offer you free lunch. But like there is a famous theorem by Wolpert. He told we cannot get any free lunch in the sense we cannot get a model which is interpretable, which is giving higher accuracy, which is robust, which is scalable in nature. What does it mean? We cannot really have one person who will understand our everything, who will be beautiful in its sense, who will be like, who will be the perfect guy. There is nothing called perfect. So we are not going to get any particular algorithm which will be interpretable, which will be giving high accuracy, which will be simple to understand, which will be helping us for high dimensional data, which will be helpful for large scale data. It's really impossible. That's why the term bias variant trade-off came into picture. So that's what no freelance theorem is. It's really a very nice theorem. There are 2-3 theorems based on that. No freelance theorem for optimization, no freelance theorem for supervised learning by Wolpert. Okay, 2002, 1996 and 2002 perhaps. So that's all about basic neural network. So in the next session, because that is going to introduce you with the deep neural network architecture, CNN algorithm. But like what I tried to incorporate, neural network is a complex system like our brain is, but it's simpler than our brain really is. Our brain is really that complex, but neural network, feed-forward neural network, it's a simple neural network of a particular fly or of an insect. So how it actually works, it has a hidden layer which calculates some weighted sum of the weights as well as the inputs, and based on that it activate some activation function in between that to classify whether put it in particular class, in that particular class or other class. So we have a large set of books which introduces us with machine learning, and it's really complex to choose a particular book. But I know you don't have enough time, or maybe you don't have enough pleasure to read a particular book because of your hectic schedule of your MSc classes going on. So pick up a book of 100 pages. The 100-page book on machine learning is there, which introduces you a lot of all the stuffs with very beautiful and lucid manner. Then you can go for the ESLR book by Tifshirani, and the current state of the arts are really described in this deep learning book by Benjo, Ian Goodfellow, and Lekan. And then there are some other books called, those who are really interested in doing PhD in theoretical machine learning, go for Machine Learning, a Probabilistic Approach, written by Murphy. That's a really interesting book that I read while I was like joining my PhD. So next, I have a series of links for you. So these lectures are going to be very small and concise, so it's really difficult to cover everything in a 45 minutes talk. So I have given all the lecture notes as well as the lecture videos by famous persons in this particular thing. There are 9 famous blogs here other than mine. That's not famous, but like if you really start exploring it, may get famous. So I have Radford M. Neal's blog. He's a Toronto statistician, very famous. Sebastian Ruska's blog, you will really like it. Then Patrick Winston's video lectures, Andrew Ng's video lectures, that's the state of the art in machine learning, we call. So that's the best person who teaches us machine learning. And I have my my co-supervisor. He used to be my co-supervisor, but he died. That's a pathetic experience with me. Professor C. Mukti, who taught me pattern recognition and machine learning, he has all these video lectures available in this link, and all the other free dataset, free resources are there. Okay, so you are going to explore them all and understand how all these are really working. So that's all, and all my best wishes for you. I think machine learning is like the way you learned how to brush your teeth, the way you learned how to speak, how to really walk. So that's what you have to do it again. You have to play with the data, understand the data, see the data, build model by yourself. You will fail regularly. Like I really remember at class 7 when I tried to like learn bicycle. I'm really a short guy, so it was really difficult. My legs couldn't reach the pedals, so I used to fell down from the cycle. I used to get up and learn. So that's what we are going to do. Try to implement whatever algorithms you learned based on one particular data. Use help of Kaggle, use help of GitHub, and anywhere. Try to find out which algorithm works better for one particular data, and you will be understanding this here. These algorithms fail, and you are most welcome to ask me question when what fails, how to do particular these things, whatever questions you have in the chat box, and I'll be answering them. And the next session will be beat on Python application of these algorithms, particular algorithms what I have talked about. So all my best wishes, and this particular workshop was meant for those who are really eager to learn. I am surprised to see we have got 50 outstanding such students who are really eager to learn, and they are really enthusiastic in the manner like we are getting old, but when I really interact with very young MSc students, I really get like evolved in this particular, even in this particular pandemic situations. It's really great to talk with you. You are most welcome with your questions. Let me ask you a few questions based on that. Okay.
Yeah, thank you, Mr. Chakraborty. I'll now pass on this session to Dr. Dipanshu Vishwas, who will take up this question answer session. Dipanshu.
Thank you, ma'am. One question from Hena Palta is, sir, how do we go from the hidden layer to the output?
Yeah, can you please repeat your question?
How do we go from the hidden layer to the output?
Yeah, so that's what I have explained in the image. We have output layer Y is calculated based on based on this particular formulation. So we have a V matrix. V is like a set of weights based on the second hidden layer to output layer. The weight set of weights V1, V2, Vk are restored in a V matrix. So how do we really calculate V? That's based on the hidden layer calculation. Okay, so V equal to V1, V2, Vk, where Vks are calculated based on the back propagation. So we have Vk, V transpose cross H. What is the H? H is our that matrix which is function of W transpose X. So Y equal to V transpose H. Based on that we can go from this particular first hidden layer to the final hidden layer.
The next question from Supriti. What is the role of VI, V2 and VK?
So it's like this. I'm telling you this thing. Your ear is hearing all these things, and you are going to finally recognize few of the things, and you are finally going to ask me this question. So your understanding and connection with your question is the hidden neurons in that layer. So it is getting connected between your understanding of my sayings, and based on that what you are going to finally ask, that mapping, that mapping is done with the help of those particular hidden neurons between the first hidden layer with the output layer. Okay, so V1, V2, Vk, all those weights, all those connectivities between those final outputs along with the hidden layer.
So next question is from Ratan Thakur. How we choose the hidden neuron which optimize our result?
Yes, that is really done by backpropagation algorithm. You are going to finally, how do you really understand the algorithm is good or bad? So we have to minimize for classification base risks. In regression problem, we have to minimize mean square error, right? So that's what we do. We minimize the L1 risks, and to minimize that, the minimization problem is very difficult. That's what we deal with backpropagation algorithm, and that's what done by stochastic gradient descent algorithm. Okay, so you have to learn about stochastic gradient descent from optimization classes. I didn't get into details because it's highly theoretical. So maybe if you have some time, go to the video lectures links given by me. So Patrick Wilson and Andrew Ng really described how this gradient descent works, but it is done by stochastic gradient descent. And number of hidden neurons in the neural network, that is one classical optimization problem. It's mostly done by cross validation. So we do cross validation and find out. But in reality, there is one in layman's term, people choose neural network is k equal to some people choose k equal to root over n. Some people choose 2/3 of the input layer. Like that, there are some possible ways to choose neural network people have really talked about. Okay.
Sir, another question from Ratan Thakur.
Hmm.
While performing the AND in MATLAB, what is the difference between Levenberg, Marquardt, Bayesian regularization and scale gradient algorithm?
While performing NN in MATLAB, I haven't used NN in MATLAB, honestly. So I do not know. I mean, you are talking about some packages, right? Like that. So I haven't used that. But if you really ask about me Bayesian regularization, it's like it's always better to go for Bayesian. Like, let me ask you a question. What is the chance that your neighbors are having blood cancers? Is it 50%? Any particular neighbor is going to have blood cancer 50%, will you say? You will say, no, sir, I really will not answer this like this. I'll say less than 5%, something like that. But how did you really know that? Did you really collected the data of all the neighbors and telling me this? You are not, right? But you have some prior information. You know blood cancer is not a regular disease. So there comes the use of prior. So based on the number of hidden neurons, we use one particular prior for the hidden neuron. Suppose k follows Poisson distribution or geometric distribution, and based on that we are going to find out the values of k, and the hidden neurons are hidden neurons, and their weights going to be calculated based on optimizing the particular weights in Bayesian manner. Bayesian regularization principles are going to be used. So it's always good to go for Bayesian. Bayesian neural network is really one state-of-the-art model, and the Bayesian deep neural network is really now the thing which really Google, Facebook are using these days. What are the reliability measures to be chosen for getting the optimum result in ANN? So it's like the based on some cross validation technique, you are going to reduce the error probability. So misclassification rate, or like classification accuracy, F measure, along with that for like regression purpose, MSC, MAP, all this you are going to measure, and based on that you are finally find out this particular ANN you are going to have, or like you are going to move to complex network problems. What is the conditions for choosing the function f? There really are not any particular algorithm for choosing that. To my experience till now, ReLU is working really well for a large set of data sets because it's computationally easy to calculate for large scale data sets. But like people are usually using logistic sigmoidal function over the years because it has some essentially good criteria like 0 to 1, it lies between 0 to 1, it's increasing, decreasing, all these properties, like increasing property, as well as the nature of curvature type nature. This type of natures, S-shaped nature, is very helpful for performing your classification tasks. How we choose the nonlinear activation function in software? So in software you have the option privilege to choose TANUJIT, or you are going to choose the logistic sigmoid. So there is option for log-seq, there is option of TANUJIT, there is option of ReLU-seq there. So you are going to finally find out your particular activation function based on that. Okay. And you have some other options there. One Indian guy recently came up with a very new activation function and incorporated it in Python. So there are large scale of works are going on. You can also come up with your own activation function. That will be a new research area for you. So if you can really show it's going to happen for ANN and RBF and all these structures, you are really going to get it there. Sir, I am using MATLAB, but I have not getting these options there. Ratan, I don't have any idea about MATLAB implementation of neural net. Maybe if you ask me about our Python, I can really tell, but I don't use MATLAB because MATLAB is like takes a lot of time for me to work with my type of data sets. It really works well with Python and R. That's why I didn't go. It's mainly for mathematical optimization and all these stuffs. So I really stick to R and Python. Any other question? Do ask, because like you can ask anything about other algorithms as well, because this is today is the almost the last session on supervised learning. Tomorrow we'll be having classes on unsupervised perhaps, and one forecasting techniques. That's also one supervised learning thing, but like in other sense classification is not going to be there.
Dear student, if you have any question, you can post your question in chat box. So I think no more question is there.
Yeah.
Now
Okay.
I would like to proceed for next session.
Yeah. Okay. So I'll suggest let us take a break of 10 to 15 minutes, and then let me come back once again. And the second session will be very of less time, because I'll take 30 minutes, even less than that, because I have taken already 1 hour for this particular session. So second session will be of less time. Okay.
Okay, thank you, Mr. Chakraborty. But
Yeah.
I think Dr. Munmun Bishash has a few announcements to make to the participants. I now request Munmun
Yeah.
to please do. And thank you very much for such a lucid and wonderful lecture. I'm not a person of statistics, though I have an interest in that. So you made this session very, very interesting, and it was very, I mean, informative, as well as it was understandable also. Like machine learning is something I think which is of interest to a lot of people, because we are right now in the digital area, and we have to be into this. Okay. Thank you very much, sir. And Munmun, please take over.
Yes.
And
okay, then 12:30 we are going to start. Is it okay, Tanujit? It is already 12:15, not 15, 13.
Yeah,
Okay,
yeah. Let us start by 12:30. Okay.
okay, the announcement is, as I said, you earlier asked about your suggestion about your evaluation. So what we have decided, we will have a 10-mark short exam, like there will be 10 questions, and the syllabus is the overview and all the topics covered up to today. Tomorrow at 9:30, we are going to have, you are going to have your exam session. So at 9:30 we'll set a meeting, and there will be a Google form format, and with the 10 questions with multiple choice type answer. In each case there is only one answer will be correct and no negative marking, and everything will be very simple. So just don't get afraid about it. At 9:30 tomorrow we'll have the exam, and that will take 30 minutes time. At 10 you just whatever answer, you just fill them up and submit. So that is the simple examination process, and that is all. So that is one announcement. So 9:30, you will all of the 50 participants have to just join the meeting and give this exam. I'm putting the details of the exam in the WhatsApp group of the participants, so don't worry about that. Those who are not present now, they can also have the information. And since tomorrow is the last session, last day of the workshop, so and tomorrow also we have two sessions, first session and second session, and as Tanujit also described. So after 4 o'clock, when our second session ends, there will be a continuation. We will have we are planning for an ending ceremony type of program, a small one, not very big one. So you can just okay. So in the end session also, we are expecting all of the participants, and also you can share your views there. You can unmute yourself and put on your videos and give us feedback. We'll also be giving you a feedback form after the ending session, and that form you will fill it up and send us by email, and we'll giving you the certificates by the email. That is one. Two other information. One is the feedback form. We will be giving you tomorrow after entire program, and after 4 o'clock tomorrow's two sessions over, we'll be having a ending ceremony or ending program type. So please be present there and share your views about the whole workshop. So 9:30 the exam. Lot of things for tomorrow, and everything will be sent to you by WhatsApp message and mail as well.